Hello everyone, I'm Ayush Singh pursuing BE from Sri Venkateswara College of Engineering, and today our topic is applications of polar coordinates. So let's first discuss with what are polar coordinates. Polar coordinates offer an alternative way to represent points in the plane, just like rectangular coordinates. Instead of using distances along perpendicular axes, they use a distance from a fixed point and an angle from a fixed direction. The key elements include pole, the fixed point analogous to the origin in rectangular coordinates. It's often marked as O. Polar axis, the first fixed direction usually coinciding with the positive x-axis in rectangular coordinates. Radius, the distance from the pole to a point P. Angle, the counterclockwise angle between the polar axis and the line segment connecting the pole and the point P, measured in degrees or radians. A point in polar coordinates is represented as an ordered pair r, theta. For example, the point 2 units away from the origin at an angle of 60 degree would be written as 2, 60 degree. But what are the use of polar coordinates, or why we use polar coordinates? Polar coordinates sign in specific scenarios like motion around a central point, describing the position of a planet orbiting the sun or a particle moving on a circular path, is much more natural with polar coordinates. Spiral and other curves, many curves like spiral and rose curves are easily defined using polar equations where r is expressed as a function of theta. Certain physical phenomena, problems involving forces emanating from a central point like electric fields can be conveniently analyzed using polar coordinates. Polar coordinates find applications in various fields including navigation, physics, engineering, and computer graphics. We'll be talking about these points in detail in further slides. Applications in physics. Polar coordinates find widespread applications in various branches of physics due to their natural representation of circular and radial phenomena. Some specific applications in physics are circular motion. Polar coordinates are particularly useful in describing circular motion. The position of an object moving in a circle can be easily represented using polar coordinates, where the radius r represents the distance from the center and the angle theta represents the position along the circular path. In electromagnetism, especially when dealing with antennas and radiation patterns, polar coordinates are often employed. The radiation pattern of an antenna, for example, can be conveniently described using polar coordinates to represent the angular dependence of the electromagnetic field. In wave propagation, they are used to describe the propagation of waves, especially when dealing with waves that exhibit radial symmetry. For example, in acoustics, the wave front emanating from a point source can be described using polar coordinates. Applications in engineering and technology. They are widely applied in various engineering and technology fields, enhancing the analysis, design, and understanding of systems exhibiting circular or radial symmetry. Some specific applications in engineering and technology are: they are used in machine designing, especially when dealing with components that rotate or have circular features. Engineers may use polar coordinates to describe the motion of cams, gears, and linkages, making it easier to analyze and design mechanisms with rotational elements. In robotics, polar coordinates can be used to describe the motion of robotic arms or end effectors in a polar coordinate system. There, this representation simplifies the planning and control of movements in tasks that involve circular or radial paths. In signal processing applications, they are employed to represent and analyze signals with sinusoidal components. For instance, in the field of Fourier analysis, polar coordinates are used to describe the amplitude and phase of sinusoidal signals in the frequency domain. Applications in biology and medicine. Polar coordinates also find applications in the field of biology and medicine, providing a convenient representation for phenomena with circular or radial aspects. In genetics and cytology, polar coordinates can be used to analyze and describe the structure of chromosomes. The centromere position, arm length, and other structural features of chromosomes can be represented using polar coordinates, aiding in the study of genetic material. In neuroimaging, such as functional magnetic resonance imaging or MRI, polar coordinates may be used to represent and analyze brain activation patterns. This representation can help visualize and understand brain activity in relation to specific tasks or stimuli. In pharmacology and drug delivery, polar coordinates can be employed to model and analyze drug release kinetics from various delivery systems such as microspheres or nanoparticles. The radial symmetry of drug diffusion can be represented using polar coordinates, aiding in the design of controlled release formulations. Conclusion. Throughout this presentation, we have explored the fascinating world of polar coordinates, where points dance to the rhythm of distance and direction. We have seen how this seemingly abstract system unlocks elegance and clarity in diverse fields, from celestial vaults to the intricate gears of machines. But the journey doesn't end here. Polar coordinates continue to inspire new applications, pushing the boundaries of our understanding. In physics, they illuminate the intricate dance of forces around charged particles and chart the grand paths of planets. In engineering, they guide the design of gears and cams, ensuring smooth rotations in the heart of our machines. Even in the realm of art and animation, polar coordinates lend a hand, shaping mesmerizing spirals and bringing characters to life with fluid movements. Polar coordinates are not just a mathematical tool but a lens through which we can see the world anew. They remind us that sometimes the most captivating stories unfold not along straight lines but in graceful arcs and mesmerizing rotations. That was all for this video. If you like our video, do consider liking, sharing and subscribing. Thank you.